Hello, everyone. I'm Jeff Brock. I'm the Dean of the School of Engineering and Applied Science. We're going by the moniker Yale Engineering, just to drive the point home. This is the Dean's Invited Speaker Series, which I'm really pleased to inaugurate. We had the idea that it would be a good way to announce our new strategy to the community by inviting really affiliates, friends from industry that have taken their Yale experience in some way and turned it into a bright, illustrious career in industry in one way or another. And our visitor today, Catherine Guarini, is the embodiment of this. She has become a good friend over a few meetings. We have some commonalities in our Yale experience. Like me, she met her future spouse while engaged in an extracurricular activity, in her case, the Yale Herald. In my case, I was moonlighting in a James Joyce seminar. So be careful which extracurricular activities you choose. You may end up reliving them throughout the rest of your life. So I'm also really excited to have you hear about her story, her trajectory through her time working in industry and the different twists and turns that's taken. But on a somewhat lighter note, I'll just mention she has recently been mentioned in as some top 10 ranking in a list of 100 most influential women that included Taylor Swift, Simone Biles, Beyonce, and who's the other one? Yeah, anyway, so we're in the presence of some celebrity here, and the School of Engineering and Applied Science, in our Applied Physics department in particular, thank you Vidvids for joining us, generates a lot of celebrity in the world, and Catherine is among them. So we're very pleased to welcome her. She's going to give about 30 minutes of presentation and talk about her trajectory, and then we'll have plenty of time for some Q&A, which I'm happy to host. So welcome, Catherine. Thank you for coming.
Hi, everyone. Thank you so much. It's really great to be here. I graduated in 1994, which sounds like a really, really long time ago, I'm sure to all of you. I was in Morse. I was an applied physics major, and I really have wonderful memories of my time here at Yale, so it's always nice to come back. And I'm going to share with you a few things today. I have, three main topics, and really this is meant to be sort of a teaser of topics that I'm more than happy to talk about. So when we get to the Q&A, if there's anything that you'd like to hear more about or ask me questions, then I'm happy to discuss. But I wanted to first talk a little bit about my career. What did I do when I left Yale, and how did that transpire into a series of different opportunities? I think Yale really prepared me well, but I had no idea where I would go next, and I will tell you a little bit about how that played out. I'll then talk a bit about technology and transformation and my role at IBM. I spent 24 years in different capacities, largely trying to drive innovation and transformation leveraging technology, and I'll give you a little bit of a feel for what that has looked like for me. And then I want to spend a few minutes talking about the other aspects of being a leader, particularly a leader in the technology industry. It would be great if we could only talk about science and engineering, but in reality, that's fun and important, but not sufficient to really drive impact. And so I think there are a lot of other aspects of leadership, leading teams, driving execution, managing crises, and others that I learned on the job. And I think there's a real opportunity to think through some of that, perhaps ahead of time, and be better prepared than I was as I got into some of these experiences. So let's start with career first. I imagine some of you think of a career ladder or some idea of some long-range plan. I always admired those people who were really clear about what they wanted to do when they grew up, and I never knew. In fact, while I was an applied physics major, if you had caught me in my first or second year here at Yale, I probably would have told you that maybe I was going to be a political science major or an Italian major or art history, or maybe I wanted to go into journalism, or who knows, all sorts of things. And then I ended up focusing on applied physics because it was hard. And I liked solving hard problems, and I liked figuring things out. I had, my grandfather was a math teacher here in New Haven, taught at the public schools, Hill House High School, for many, many years. And for as long as I can remember as a kid, he thought doing math was the best thing ever, and he made me think that math as a tool for solving problems was fun. And so when I got to actually apply it to solving problems like in physics, I thought that was fun too. So after I got my degree in applied physics, well, actually before I got my degree, I actually got a chance to work as an intern at Hewlett-Packard out in California. And this was summer of 1993, so it was sort of the heyday of Silicon Valley, and a professor here, Robert Wheeler, who I think is now retired, but he connected me to one of his former students who was working at HP. And that's how I ventured out across the country and spent the summer working in industry in the tech world. Taking measurements in a lab, writing code, trying to figure out what you do with an applied physics degree in the real world. But what an experience being in Silicon Valley, and I decided to go back. So I ended up going to graduate school at Stanford down the road from HP in Palo Alto, California, and being a part of the Silicon Valley community at that time was really stimulating. I went back to HP for another summer. I did an internship at Advanced Micro Devices, or AMD, who is now a tremendous leader in the industry. They were playing second fiddle at the time to Intel and semiconductor technology and manufacturing, but I got a chance to see what it was like to take some of this science that I learned in school and actually apply it in the real world. As a graduate student, I worked with a professor named Calvin Quate. He was about my grandfather's age. I was among the very last of the students he had. He looked like Einstein, big, white, crazy hair. He was the co-inventor of the acoustic microscope and the atomic force microscope, or AFM, that some of you may know about. And at the time, everyone was talking about the end of silicon scaling, Moore's law, that you wouldn't be able to pattern using light and using traditional optical lithography any longer to shrink the transistors and scale the microchips, and therefore we wouldn't get faster computers. We wouldn't be able to have better electronics, and there's lots of worry at the time about this. World has changed, and we still have faster computers and powerful cell phones. But at the time, everyone was thinking about how can you scale how small something you can pattern? How do you make better transistors that can actually turn off when they get to the dimensions around a few atoms thick? And so that was what I did, and I got to get in a lab, build transistors, use these scanning probes to do parallel patterning, emit electrons from a probe, build transistors, build chips, test them. So it was a hugely interesting experience, right? Really trying to learn how to actually build things and demonstrate value that the industry was looking for. So when I finished my degree, I came directly to IBM. And then I spent the next 24 years at IBM. So a long time, but doing so many different things. I started doing technical research. So my first 6 or so years, I was working in a lab. And I was taking some of that experience I had in graduate school and doing internships and actually applying it to what IBM did, which was to actually build semiconductor technology for their systems business, building microprocessors, building all the chips that were in the competing game stations, the Nintendo chip, the Sony, the Microsoft Xbox chip, and so on. They needed to have high performance technology to deliver that. And so I first was in the research lab, experimenting with new transistor designs, new structures, new materials. And then I moved into the development space, which is how do you get these to yield reliably? How can you build them at scale and ensure that we have a business that is going to be productive? And then I got a chance to move around the company outside of that semiconductor and research development space because I wanted to know what the rest of IBM did. And I'm going to tell you all a little bit about IBM because I didn't know. All I knew was this little research world because as a graduate student, I'd read papers from researchers at IBM, and I thought, I want to do that. but I didn't really know what the rest of the company did. So I deliberately moved outside the research division, got a chance to work in development of our microprocessor design. I was managing a large global team, designing microprocessors. Again, I'm not a circuit designer, but I was leading a team on that. Moved into product management. How do we launch net new products? We wanted to bring a technology, the mainframe technology had been around for 50 years at that point. We wanted to bring that technology known for reliable, secure, highly available computing. We wanted to bring that to new workloads and to new clients that had never used a mainframe before. How do you do that? Well, we actually leveraged the open source operating system Linux on the mainframe technology. We launched a new brand we called Linux One. We went out and talked to clients and said, how do we get you to use this product? What is inhibiting you? Is it skills? Is it user experience? Is it functionality, performance, latency, et cetera? So bringing that back and then working with our development teams to design the next generation of that product. It's a completely different type of experience for me. How do you price it? How do you go to market? Where's the product market fit? Who is the competition? It's a completely different set of questions and answers. And then I came back to the research division after having been outside of that for almost a dozen years. And I worked as the chief operating officer for the research division. IBM Research has 3,000 researchers, largely PhD, mostly doing very deep technical work, some exploratory, more academic life-like, and some very closely collaborating with our development teams and that whole spectrum. It's been around for 75 years, this research division, but we were worried about going the way of Bell Labs and other industrial research organizations that aren't around anymore. And so my role as the COO was, how do you make sure we're relevant? How do we increase the impact but not lose that very special capability that was able to have Nobel Prize winners and to have very, very high recognition for the innovation in the research division. And then I spent the last 2.5 years as IBM's CIO, which is the Chief Information Officer. And I'll tell you a little bit about what that role is, because again, I didn't really know. I didn't really know what the role was all about. And it's different in different organizations. But suffice it to say, large organization, big set of deliverables that the company was relying on, and I got a chance to use a lot of the skills I had developed over the course of my career to figure out how do you solve both technical problems, but also some of the execution and leadership and other aspects of leading in innovation when you have high stakes, because at that point, all IBM employees and all IBM clients were then relying on the CIO team to deliver the IT and the capabilities to do their jobs. So, if I can go forward here. Let me just tell you real briefly about IBM. So it was founded in 1911, so it's been around a very, very long time, and it's changed a lot. You see at the bottom of the chart some of the things it's known for, from punch cards to computing machines, helping to land people on the moon, certainly well known for that. Watson beating Jeopardy in 2011 was a proud moment, as started to kind of understand what natural language processing and question answering systems could do. And today, the flagship product from IBM is called Watson X, and you may have seen some advertising about that recently. But what's interesting when I'll tell you a little about the IT or the CIO role is the size and scale of the company. There are 280,000 employees at IBM. It's like the size of a small country, but it does business in 170 plus countries of the world, which means you have to deal with different cultures, languages, regulatory requirements, laws, et cetera, and time zones when you're managing and supporting that community. And then the size and scale of the business, it's about a $60 billion revenue annually, and it has three main portions of the business. It still has what's legacy infrastructure or hardware business, delivering systems. It's largely what I had started in that space. It has a very growing software portion of the business, and the big piece of that was the acquisition of the company Red Hat. It's known for open source enterprise software. And then there's a consulting business, so technology and business services that IBM supports as well. And so as the CIO, I was the global person and organization responsible for delivering IT to that IBM community. So large number of people, lots of geographic spread, and working with clients in all these different industries. So this is a quick picture of what the CIO organization at IBM is responsible for, and I'll point you to this middle section. It's called Digital Workplace Solutions. It's mostly what people associate with IT or a CIO. You get your workstation, you get your laptop, mobile device, you get on the intranet, that can get IT help or support. So those, and those certainly are the things, some of the things that I and the team was responsible for. But what little did I know, the stuff on top, the business applications that actually run the company, were actually the lion's share of the investment and the complexity that we were responsible for. So running payroll systems and procurement and real estate and supply chain, all the HR systems, et cetera, finance, how do you close the books? All these applications, over 4,000 enterprise applications that we needed to run IBM successfully need to be reliable, secure, scalable, that when a client has an issue, they can get in touch with and get response times immediately. How do you modernize that environment? How do we take advantage of new technologies? How do we improve the experience for our employees and for our clients? How do we transform this and reduce how much we're spending while we're doing that? So that was the sort of challenge, and getting our arms around that and maintaining it. And then, of course, we're responsible for the infrastructure on which that is all run. And because IBM's an IT company, I wanted to be an early adopter of all IBM's technology, right? So just as we develop a new server system or a new piece of software, or we have a way of partnering with a set of strategic technologies in the industry, I wanted to be the very first to use that technology so that we could demonstrate the value. If it can work for IBM at our scale, it can work for any one of IBM's clients. And then we can also provide feedback to our development and our product teams to make it better so that IBM could grow as a business. So we had both the responsibilities sort of at the back office to support the company, but also to be out there leading edge to make sure that we're taking advantage of IBM's technology. Because you can imagine if you go to a customer and you say, IBM, we're focused on hybrid cloud and AI and what's next, we've got this great stuff, use CIO, because IBM actually sells to CIOs in the industry of banks and retail companies and so on. We've got a solution for you. What do you think the first thing that they're going to ask is? Do you use it yourself? Does it work for you? And if the answer is no, we lose all of our credibility. And so it's really important that we be out there in front. It means we're taking risk. That means we're being an early adopter and actually co-creating. All right, so I want to talk a little bit about technology. I'll just let you read this little cartoon. It's one of my favorites. Everyone's so excited about ChatGPT. And it's wonderful. I mean, how exciting that we all have AI in our hands today. It really is. But that's not the same as applying AI or any technology to large-scale enterprise environments. Because I have to worry about data privacy and confidentiality, to worry about scale and repeatability. Is it trustworthy? What data was it trained on? Can I explain the results? And so I want to use all of the technologies and the very best there is, but I need to be very thoughtful and responsible about the applications of that technology. And it's not technology and innovation just for technology and innovation's sake. It's about what problems are we solving and what value are we delivering. So I always like to start with what are the issues or what are the concerns on the minds of business leaders in an enterprise? And so here are some. There are, of course, many more. But huge pressure at an enterprise level. And I saw this at IBM, and I saw this in our clients, right? Most of our clients are coming to a company like IBM saying, help us reinvent ourselves using technology, new business models, new ways of going to market, new ways of developing products. Productivity is the word of the year, of the decade perhaps. Most CEOs, so the leaders of these companies, are telling us that what they care about is productivity. What that usually translates into, how can I be more efficient and effective? How can I get my workforce to get more output for a given input? How do I get more things done? And so AI and technologies are certainly a piece of that. But it's also new ways of working, the hybrid or remote working model. It's labor shortages, it's skill shifts. It's a huge focus. And technology can play a key role. Cybersecurity is a huge concern. Massive number and frequency and severity of cyber attacks today that are very, very costly, not just in dollars, but reputational cost and time and business value. So we need to protect against that. Sustainability has become top of mind, probably should have been for a very long time, but it now finally is clear that all of us and businesses are playing a role in impacting our climate, and we need to take responsibility for being very, very thoughtful. And technology is both a contributor as well as a potential solution in how do we address some of the pressing challenges around sustainability. Geopolitical risks, this is rising threats, this is supply chain vulnerabilities, and much more. And finally, public health, and we've just been through a pandemic, but it's not only infectious diseases, it's mental health, and it's so many other aspects of public health. We care about that at an enterprise level because it's our employees, it's our clients, it's society at large. And so if you think about, these are a set of the problems that we see in front of us every single day. Technology and innovation can play a role in addressing this, but it's not just about how many applications of AI do you have? Interesting, but more important about the so what. What are you doing with it that's meaningful and impactful to the company and to the organization? So I'll highlight just 3 technologies that I think are important today. There, of course, are many, many more, and these are in different levels of maturity. I'd say hybrid cloud or cloud computing today is very much mature and available set of capabilities, but still in its infancy in terms of wide-scale adoption. And by that, we largely mean, the legacy world was all these distributed data centers all over the world. When I took on the job of CIO, there were 74 different data centers where IBM was running workload for our internal use all over the world. I mean, I think about it. How do I even get my arms around that? Where is everything running? How do I secure it? How do I think about the sustainability? What's the carbon footprint of all that? How do I manage latency and performance and user experience? How do I modernize something that is that fragmented? And so by moving to a true hybrid cloud, and by that we mean a combination of on-prem, private, and public cloud, not one public cloud answer only, because that typically locks you into a solution that may not be any better than you were before, but having some flexibility to be able to move workloads across different environments. If I maybe have a change in the requirement from a client or from an employee, I want to be able to have more flexibility, which I didn't have in the old legacy environments. We've moved a huge amount of IBM's workload into this more flexible environment, and we're seeing tremendous benefits in terms of how quickly we can deploy applications, how much money we save, and frankly, the carbon footprint piece as well. AI, I mean, this is the hottest topic today. I'm sure everybody here is talking about it, thinking about it, using it, which is great. As I said, it's really about the responsible use of that technology. So we have a number of enterprise applications. In particular, we've used robotic process automation, or RPA, to automate manual tasks. This isn't about displacing workers. It's actually about getting off of their plates a lot of the more mundane tasks and freeing their time and energy up to do higher value work, which is important and needed and frankly valued by our employees as well. We had a number of applications like automating HR and IT support using AI. So you don't have to wait on a call center and worrying about what hours is there someone there. We're used to this, in the consumer world. But many enterprises don't have it because they worry about security and privacy in many of their aspects. But at this point, if I want to transfer an employee at IBM or do a salary increase or do a whole host of other HR tasks, they can almost exclusively be done through digital assistant, chatbot, AI technology. It can be done 24 hours a day. It can be done with inline language translation. If you're in a part of the world and you don't speak English, you're not comfortable. It gives you a lot more flexibility, and we just applied some very similar technology to providing that IT support. and quantum computing. So Yale also is very big in this space. IBM has invested. This is what we have today, but I think there's still opportunity, very much opportunity into the future on how do we leverage new computing technology, not to take over, not to replace traditional classical computing, but to be able to solve some problems that simply can't be solved with the technology that we have today. It's very exciting. The work that IBM in collaboration with a number of partners is advancing this capability very fast, and we're seeing that now people can actually solve some really interesting problems, starting to see quantum advantage. This is 433 qubits or bits that are available for quantum computation today, with a commitment by the end of the year will be 1,000, and before long, tens of thousands. I mean, that's a term, I honestly, truly didn't think that was going to be possible in our lifetime. It's an amazing level of progress, but it's interesting on the technology, but then what do you do with it? So the applications, the use cases in quantum chemistry, in finance, and optimization are really compelling. And the network of universities, startups, and large Fortune 500 companies that are starting to explore what quantum computing might do for them. It's very exciting. There's also the fear factor, which is, oh gosh, when we have large-scale quantum computing, this will be able to break traditional public key cryptography. And that's true. But there are new cryptographic algorithms like lattice cryptography that are robust against large-scale quantum computing, but then that takes us back to our cybersecurity focus, and what do we do to make sure that we're really prepared for quantum computing, take advantage of it, but we also protect against some of the risks that any technology brings. All right, and then my last section is about leadership. And one of my favorite cartoons here, because I think it's so telling. Most people think, oh, great, you're the CIO, so you just tell everybody what to do. That must be pretty straightforward, right? Jeff, you're the dean, right? You just get to tell everybody what to do, right? Really and that would be nice, but the reality is, and you all know this, leadership is messy. And it's complicated and it's challenging in many ways. And so I thought I would highlight some of the aspects of leading, whether you're leading an IT team or a product development organization or a research community or launching net new products, that you need to think about that are outside of the bits and bytes, outside of the science, but are critically important to success. So the first is when you're driving these projects, there's a whole host of things that we do as leaders that need to be thoughtful about what does success look like? What are we really trying to achieve? And how will we know we're making the necessary progress to deliver? So there's the strategy aspect, the project planning, the budgeting, the prioritization, what guardrails do you have in place? What metrics and measurements? What governance do we have? And this stuff is not all that straightforward. Depends a lot on the team and the priorities and how, but hugely important to success. And again, it almost doesn't matter what you're trying to do. You're trying to deliver a new mainframe system to the market, you're developing quantum computing, you're trying to create an innovation through AI and delivering it to 280,000 IBM employees. You have to be clear on what does success look like and how do you ensure that you can deliver on that commitment. But there are always risks, always. So how are you thoughtful and proactive about identifying what those risks are, and how do you minimize those risks but also prepare for the eventualities of when something goes wrong, because it always does, right? Have all sorts of crises stories that I could tell, but I will tell you one that will probably make you laugh. We moved to a new mail system a couple years ago, and as the CIO, it was one of the things that I was responsible for. One of many things, and it didn't think it would raise to the top level of my focus and attention. But when you move 280,000 employees to a new mail system and the system goes down and they can't access their email for upwards of 2 weeks, that's a crisis. Made the paper. I had to record all sorts of communications to the entire global community, to talk to our CEO on a daily basis. We had to put an action plan. It wasn't something we could just switch a button and be back. There were technical challenges, there were leadership challenges, there were communication challenges, there was root cause analysis that we needed to understand. And then once we got ourselves out of that crisis, we needed to make sure that we were clear how we would prevent anything like that from happening again. So how do you learn from that experience? And not just Catherine learning, or not just the leader of the project learning, but the organization at large, right? How do you help the organization to be better for any of the issues and concerns? And then perhaps the most important thing, and if you remember one thing from my story, it's all about the people. Because you can do great science, and you can have interesting project plans and crisis management proposals, but it's all about the people that you have to get your projects done and to inspire and to drive innovation and to do delivery. And those people, right, they require hand-holding and support and inspiration and leadership in order for them to be most effective. How do you build effective teams? How do you build a multidisciplinary set of capabilities, people with different expertise who understand the different cultures and geographies and laws and disciplines? And how do you help them to work together effectively if they have these different perspectives and experiences? How do you reward or incent the right behavior? How do you provide performance feedback effectively, coaching? And you manage your team effectively. All of this is sort of not taught in school, I would say, but so important to the success of any of these projects. In my experience, what we tend to not recognize or even prioritize enough, even from those of us who have risen through the ranks, who have a PhD and vice president experience and leading large organizations. Because I'll tell you, the first time I had a 500-person team and we're trying to build a microprocessor, and you have billions of transistors that all need to be connected together in a way that you can tape this out on a specific date 18 months from now. Well, now you have the complexity of managing that schedule. You have the technical hurdles that need to get done. How are you going to have the right latency and performance and so on? You have the personnel aspects. Do you have the right skills and capabilities, roles and responsibilities? Who's going to be making the decisions? What happens when all of a sudden 6 months in, there's a new opportunity or challenge? There's a competitive issue. There's a technical issue. You have to have these kinds of experiences and skills in your pocket so you can pull them out and respond. And if you don't, you learn on the job, and you find mentors and you find others who can help you to be effective. But for sure that you don't do the things that I've been talking about with science or with engineering alone. It's super important. I think the credibility of understanding the science and engineering to many of these leadership positions has been very important for me. But to couple that with some of these other aspects of leading, executing, and driving teams, and the inspiration part, because in the end, you're going to have hard things. There'll be hard days and projects and challenges, but you need to have the team with you, right, who are excited and about coming in every day and working as partners to try to solve these problems. That goes a hugely long way into the overall success. So the very last chart, before we open it up for questions, you've heard about a lot of things that I like to talk about. I decided a few years ago during COVID, when we were all stuck at home, that I would start a blog and write about some of these topics, whether it's leadership and work-life balance and what it's like to be a woman in a largely male-dominated hardware technology space, or science and innovation, et cetera. And one of my favorite things is when someone will say, oh, I read that and I agree, or I disagree, or I had a similar experience, or I'm also struggling with that, or my husband also does the laundry, or whatever the story happens to be. So it's been a great conversation starter. And as Jeff said, my husband also went to Yale, so he happens to be wearing a Yale shirt in this picture. He was in Silliman, right near here, and we met working on the Yale Herald. So we've got a science, and he's a social studies teacher, and so we got different sides of the brain. And we have 3 children, 2 in college, 1 in middle school, and it's been an adventure. right? Lots of fun, lots of learning, and my favorite thing about being in the technology space, as I said, it's hard, but there's always something new to learn. There's always something new to learn about the science and technology, but also in all those other aspects of leading projects and driving execution. And it's been a wild ride for me. I've got a chance to learn over many, many years, and I look forward to learning more going forward. So with that, I will open it up.
Great, thank you so much, Catherine. Okay,
Yeah.
Great, we get some seats. I also do the laundry, by the way, just full disclosure. So I want to open it up for questions, but I have a couple questions of my own,
Okay.
if I may. The first is, Yale prepares us in various ways for various things. What would you say is the thing you remember about your Yale experience that has helped you the most? And what do you wish you had learned here
Interesting questions.
that they missed, we missed?
So one of the most pivotal experiences I had was as a leader on the Yale Herald, or the weekly newspaper, and not just because I met my husband, although that was also pivotal, but being in a leadership role with people who didn't have to, weren't getting paid, right? Nobody had a job and was really worrying about so much on their resume. But it was because people felt like they wanted to be a part of the team and that they felt valued and that we all made it fun, but we also cared deeply about the quality of the output. And I think that experience, perhaps more than anything else, is something that I took forward into other leadership roles that I had. And so that's something I absolutely remember, and just working with brilliant people and being in a community of smart and motivated, ambitious, but collaborative people. That's something I really valued in my time at Yale, and I've looked for. And one of the things about IBM is you're working with people who are deeply smart and motivated, and not so different perhaps in the community here. So absolutely have enjoyed that. What do I wish? So I learned so much from a technical perspective in the applied physics. Applied physics was, and I think still is, a fairly small department, and I was deliberate about that, and I stayed in an applied physics program in graduate school as well, because I liked that basic science, but also applying it to real world problems. I sought the industry experience and reaching out. I would say I didn't feel like there was a lot of, I got lucky that I have a professor who connected me to somebody, but I think the opportunity to learn about what kind of jobs and what kind of opportunities exist out there in the world, so like what you're doing and inviting people in to share that, I think that's great. I didn't feel like I had a lot of that when I was here, and I couldn't really imagine what life would be like after, and so I just kept going, and then it worked out.
Yeah, this is a true unicorn here, the applied physics major. I don't know, how many applied physics majors are there in the audience?
Anyone?
Ah, there we go, okay, great. Yeah, I mean, that's really interesting. So, we wrestle, and the institution wrestles, I think, with the question of the kinds of, how much we should broaden the training of undergraduates to include the things that you mentioned as these really key skills that you're developing kind of on the job, right? So do you have a sense of, if we were to think about new ways to develop the curriculum that would prepare people for some of the things you didn't learn here, but maybe wish you could have, is there kind of a list of key things that you would suggest we think about?
I think there are frameworks and models for some of the things that I've talked about. And I think there's an opportunity to both learn about them, sort of the book learning of it, but also to practice it. And so I know you have experiential courses, leading teams and projects. I'd say there's very little of having a hard problem and going off and thinking about that by yourself in a room that I've experienced as in the professional world. A lot of this is team-based learning, it's figuring things out together, it's taking advantage of all these different perspectives. So I think finding ways to get that experience while you're a student so it doesn't feel so foreign when you get into the working world.
Yeah, I agree. And then I guess I have one more, and then I'm going to open it up. So, we are really eager to bring kind of like this, bring some of the knowledge and experience and even the sort of technology and technology awareness that exists in industry into how we think about teaching our students, how we think about collaborating in terms of our research labs. What do you see as the sort of positives of that, but also some of the pitfalls that universities need to be aware of as we sort of embrace technology that exists in industry?
Yeah, I think there's huge value of bringing it in and making it relevant and seeing kind of this real life, tangible, what's going on and how do you get your arms around it. But I think the pitfall is, you don't want to get so enamored with one particular technology, right? ChatGPT X is not going to be the end all be all, right, for the rest of your careers. It's more about how do you understand what led to that innovation? What are the key components of it? How do you use it? How do you understand when new technology emerges? How do you take advantage of it? Because there'll be, next year, 5 years from now, 10 years from now, it will be something else. And so it's really, I think it's important to be relevant and to be connected, but not to get so enamored by whatever it is today, because the technology in the business world is changing so fast. It will certainly be different as you progress.
Good. Okay, any questions from the audience? Yeah, right here. Sure. Oh, we have a mic, because there you go.
When you made the transition from a sort of research, sort of PhD role to a more businessy role, I guess there were a lot of skills, as you sort of said, that you sort of maybe didn't have or had to learn. To what extent did you feel like you had to be really proactive about going out and learning those versus really learning them on the job, or just sort of like using the sort of experiences to guide you?
I did a lot of learning on the job, I would say. And I think that is pretty typical, certainly at IBM. I can't speak to every other company, but I think in tech, that's pretty typical. In technology, even people outside of, say, the research and development, we don't have a huge number of pure sort of MBA business management leaders. In fact, the CEO of IBM is a PhD electrical engineer, right? Not an MBA, he's a super smart businessman, but his technical training is in engineering. And that's sort of the ethos of the company. And so it wasn't like I had to go get an MBA or I took various classes and I found value in that, but much of that was learned on the job. And in fact, my first management role, the first time I was leading a team of people and had to do performance reviews and be responsible for their success, as is typical, you get promoted into those positions because you're good at your other job, this is something every company out there does, and it's typically a mistake, but hey, you're really good at being a technical contributor, we'll make you a manager. And all of a sudden, you have people in management positions who have no business being in management positions because they may not actually be that good at the guidance of a team or the leadership of a team. They may be just really, really good individual contributors. Now, some grow into it, right? Some actually, embrace it and want, but others don't. And then that's a disservice to the people in their organization, right? They just suddenly now have somebody that is looking for the power. So for me, when I got that first leadership position, I was actually super excited about it. I wanted that, and I valued that, but I also knew that I didn't have the experience. Suddenly I was managing people who had many, many more years of experience than I did, who had, sometimes difficult to manage, right? Especially in the research community, notoriously sort of independent-minded, as you can imagine. And I didn't feel like the role of the manager, so my role was particularly valued even amongst the leadership in research. I was disappointed by that. I said, this is really important. I want to do a great job at this. And they're like, yeah, just keep doing your research. That was how I felt. I don't think that was actually accurate, but that's how I felt. When I moved into other parts of IBM, particularly into development teams, the role of the manager, it was super important. Because suddenly you couldn't get a project done. You couldn't deliver our chip design on schedule, keeping your team motivated, if you didn't have managers who were really equipped to lead these teams effectively, but also have the technical credibility that the team would listen. And so I really liked being a manager in the development organization because suddenly that role was really important. And I was playing not only a people management role, but also a project management role, so responsible for the delivery of the project. And I found that really rewarding.
Yeah. Either way, yeah. Circle around.
Did you ever experience imposter syndrome? And if you did, how did you deal with that?
Yeah, that's a great question. So imposter syndrome, for those who haven't heard of it, is very common that people feel like, well, I'm not deserving. Why am I in this position? So yes, most of us in leadership positions have. Particularly when I became the IBM CIO. So suddenly I was in a C-suite position at the company. And I thought, why me? Right? Why am I in this role? Do I deserve to be here? So, and it's very natural, right? It's, I think many of us, and it's particularly common among women, question whether you are deserving or whether you're up to the task. I think the biggest advice I have is that you're in it for a reason, right? Nobody gives you a job like this to be nice. Hey, Jeff, wouldn't it be nice? It doesn't happen. It just doesn't happen. It's too important to the business, to the company. It is not, nobody's getting token jobs. So you got to bolster your confidence a little bit to say, of course it's deserved, but then you have to earn it too. Right? So for me, it's about, okay, get over that, but then what do I need to do to make sure that I can do a great job, right? What do I need to be effective? And it doesn't mean knowing everything or being the smartest in the room or knowing all aspects. I showed you that CIO portfolio. Look, I took the job, I didn't even know that, right? I literally didn't know what I was getting into. I had been in many other parts of the company. But the reason why our CEO decided to put me in the role is suddenly they had somebody who had developed products, who knew the IBM organization, who understood how to lead large teams and drive innovation. So I was coming with a different set of experiences than my predecessor and others who had been in that space before. And I was focused on how do I bring that? How do I bring that value that I was selected for? But also, how do I learn? How do I surround myself with people who can fill in some of those gaps and have expertise where I don't? And not be afraid to ask a lot of questions. I ask a lot of questions, and it's not because I'm trying to test somebody else, but because I genuinely am curious and I need to know and I want us to explore and figure things out together. So I think those are all sort of techniques, but it's not unusual. I was just telling Jeff, I just got appointed to my first public company corporate board. And I said, well, this board is so impressive. There are Nobel Prize winners, and there are people who have been leading all the, and my first reaction was, why do they want me on that? and so I still have it, and I think it's only natural. I think it's good that you can continue to be somewhat humble and not think that you're deserving of everything. On the other hand, kind of have to straighten your spine and say, I can do this, and I'll add value, and let me figure out how to ask a lot of questions and learn, but also figure out what my unique value add is and lean into that.
Yeah.
Thank you. Thanks. Hi. It's related to the question about transition from research to management and business jobs. I guess apart from skills that are to be learned, what can you recommend on us to prepare for it, like mentally? Is there a mindset change that, because
Yes.
I guess I'm a PhD student, and as a PhD student, it's a lot of time is to make things work right on the edge.
Once.
And I take fun of that, but that's probably not the correct spirit in management. So when I feel that things can be done better, but there's compromise to make, when you feel this way, do you feel uncomfortable, and do you think there's a mindset change that we can prepare ourselves?
Yeah, that's a great question. Yeah, it certainly is different when you're doing research, in a university or even in the research community at a company like IBM. there's a bit of a luxury in that you're not looking necessarily at trying to build repeatable products. You're not looking at trying to scale a solution. You're trying to typically, drive innovation, invent, demonstrate something is possible. And boy, that is exciting, right? Something that's never been done before. You're trying to show for the first time and to demonstrate that value. So there's so much great experience from that, and not everybody can do it. Obviously, there are people who they're not programmed that way. They're not as excited by this invention and this innovation and this brand newness. But it is different when you move into a space where suddenly you're trying to deliver something at scale, where repeatability and reliability and performance and security and privacy, like all these things become paramount. And even if you have something that's been demonstrated, it's amazing, it may not have any place over here. And that's true, right? So I think one of the interesting things for me, when I went back to the research division after having been outside it for quite some time, I had a completely different mindset than I had before. So now I'm saying, well, why are we doing this? in some cases, not everything. Like, this is never going to work, right? And I had to check that too, because part of the role of research is to explore avenues that may not be commercially viable. So that's okay that some portion of the portfolio is pushing the envelope. We can't always know where it will go. So you don't want to predispose or limit or stop doing things just because there's risk. But there has to be a spectrum, and that was one of the things that I was focused on in research, is to look at a portfolio of projects, some that are in this riskier element, which is okay to not always see the commercial viability in the early days, and some that have a lower risk and more alignment to the product portfolio commercialization and so on. And as long as you're deliberate about that and you acknowledge it and you're clear-eyed, I think that's fine. But there's a difference. And if you do everything over here, I don't think the community, I don't think an industrial research lab will survive if everything is so far afield that they're shot in the dark and super high risk. But if everything in research is so close to product that it's a guaranteed home run, then you're probably just an extension of the development team. And it's probably not truly the role that a research organization needs to play. So that spectrum or portfolio, I think, is really important.
Great. We have time for one more. Oh, there you go. Yep.
So I was curious, since you've been at IBM, I guess, 24 years, and it seems relatively rare that maybe someone would stay at one spot for so long, especially in tech. One, did you ever consider leaving IBM, and were there different points, like in your career, where you really kind of checked in with yourself or consulted mentors, or even just how you thought about kind of reaffirming the decision to stay, and what value you might have actually derive from actually being in one spot instead of moving around?
Yeah, really good question. It turns out that there are not only a few people at IBM who stay 20, 25, 30, 40 years at the company. So it's not that unusual, although, at large, like the average tenure for most people in jobs is like 4 years in the country right now. So it certainly is strange on that side. If I were doing the same thing for 24 years, I would have gotten bored and left immediately. So the nice thing about a company like IBM, it's so big, it has so many different aspects to the company, that I had the pleasure of having like a dozen different jobs over the course of 24 years. So that was a real benefit to me. And why? Because I had a network of people that I had worked with. I understood the processes. I know how to get things done. I understood our technology portfolio. I could take some of my experiences in one area and move it to the other. And then all of a sudden I had a network of people I could reach out to. So in development, suddenly we had this technical problem, and I could call up my friends and colleagues and former employees from my research days and say, drive up to this development lab. We need your help. And so on. So I think that there were sort of intangible benefits of being at the same company, even though I had the chance to do all these different things. I was deliberate about going after doing different things, though. I mean, I would say there are not just a few people who come to IBM Research and stay at IBM Research. It's a large 3,000 researchers, it's a large community, but there are 280,000 people at the company. So it's a much larger company. And it was the most surprising change people said to me was, why are you leaving research? How? And I'd been there about 6 years. And I made a deliberate choice to go learn about what the rest of the company, and that's what allowed me to kind of keep learning and keep having these different experiences, which for me was what kind of kept it interesting.
Great. Can I sound you out on one last topic before we adjourn? You mentioned one of your blog posts was about what it's like to be a woman in a sort of male-dominated technology field. And I just wonder if you could, give us a sense of that and some pointers perhaps for folks in our audience.
Yeah, there's no easy answers. Unfortunately, not enough has changed, in my opinion. It wasn't so unusual when I was back at Yale to be among a few of the women in applied physics classes or in engineering classes. And that continued in my PhD program at Stanford. That continued when I joined IBM Research. There was never a line at the women's bathroom, so there's benefits. That continued when I moved into hardware development, right? Working in the semiconductor world, working in the systems development, and then even in the product management side of that hardware. So hardware tends still to be less diverse than other aspects of engineering and applied science. So my disappointment is that not enough has changed in the last 30 years as I would have hoped. I think the good news is I think there's a lot more awareness that we need to tap into a larger segment of our population for a lot of the important innovation and opportunities. They're lucrative jobs, they're exciting challenges, we want all diverse perspectives. I mean, there's so many good reasons. There's truly a business imperative, not just it's the right thing to do. But again, we're still not seeing such a dramatic change. I didn't experience overt discrimination or bias. I really didn't. There were times where I felt awkward or I felt just disappointed that I was the only woman in the room. And sometimes I was the leader in the room as the only woman, which can again feel a little bit, I'd say, uncomfortable, but you get used to it, I'd say, a little bit over time. My experience is just to not be afraid to sort of speak up when I need to, even if that takes a little bit of practice, and then speak up for others as well, right? When I see that there are women that maybe are sitting not at the table or are not being heard, or stereotypically, but actually in practice, I have seen plenty of times where a woman will say something and it's not really recognized, and a man will repeat it, and everyone says, "Oh, what a good idea." And I will often say, "We heard that 5 minutes ago. If it was that good of an idea, let's make sure we go back to so-and-so and hear what other ideas she has." So I think it's on all of us, but particularly for those who are in leadership positions, to look out for circumstances where traditionally the woman gets asked to take the notes or send out the agenda or do the things that are the extra work, when that's reasonable sometimes, but that those sorts of responsibilities should be passed around. So as a leader, I think there's more we can all do to call that out and then help to move things forward in a positive way.
Good. Well, Catherine, thank you so much for being here with us today. You're a tribute to Yale, and we're very pleased you were able to share your story with us here. And thank you all for coming. Look forward to more Dean's lectures in the future. Join us again.